Hey guys, welcome once again. This is Rave class. So last two episodes we had studied successive differentiation involving algebraic as well as product of algebraic and trigonometric. So algebraic and product of algebraic and trigonometric functions I hope you have learned in a simple manner. So the more and more complex problems can also be solved using these simple results that was listed in the previous classes. So in this today's episode 3, let's see some of the problems involving exponential functions as well as logarithmic functions. So in exponential functions, let's begin. So the given equation is y is equal to e power x sin x. So the given function is y is equal to e power x sin x. Why I'm considering only sine here is quite simple, and I'll introduce even cos so that you'll know the changes in the sign. So what is successive differentiation? Again is differentiating the functions again and again, so I have to find second differential, that is y double dash over here. That is the question. So let me begin without wasting any time. So I'll consider this as to be equation 1. So in the similar manners as we discussed in the previous classes, the first differential, that is y dash, will be found. So again this is a product of exponential as well as trigonometric function. So the same rule, that is product rule, applied over here. So the first function as it is, that is e power x, and the differential of sin x gives you cos x. See, here is the term that makes you simple. If you use cos x over here, you get a negative sin x. That is negative sin x, that is minus sin x. So in order to make the class even more simpler, let's start with the basic things. So here it is, it gives you cos x plus the second function, that is sin x, is kept as it is, and the differential of e power x. So the differential of e power x is nothing but it is e power x itself. So it is quite tricky, isn't it? So e power x, the differential of e power x gives you again e power x itself. So the exponential function involving the product of both exponential as well as trigonometric is quite easy in the product rule, because it gives you the same function, that is e power x. So now you can see this particular equation over here, which I'll call it to be equation 2, which has to be differentiated once again with respect to x in order to get y double dash. That is nothing but d square y by dx square. So if in case there is two types or two methods that it can be solved, so I'll write the equation 2. So this is one form where it can be written. So other form is y dash is equal to e power x. So e power x and e power x is common to both the functions, so cos x plus sin x. So now here you can see that in this particular equation 2, if you differentiate once again, you have to apply the product rule twice, right? But in case over here, the product rule has to be applied only once. So making it more simpler, and it derives only fewer steps to solve the problem. So let me differentiate equation 3. So differentiating equation 3 with respect to x gives you what? Y double dash is equal to, so first function is e power x, and differential of sum, it is a sum over here, so you can directly differentiate each and every function. So differential of cos x is minus sin x, plus differential of sin x is cos x, plus second function, that is nothing but cos x plus sin x, and differential of e power x is what? E power x itself. So is it really simple, isn't it? So you have to just note here is differential of cos x is minus sin x. It's really important. So now the main thing over here is to rearrange terms. So let me explain this step also over here. So multiplying here, it gives you e power x sin x. So this is the function that you get, that is the minus e power x sin x plus e power x cos x plus e power x cos x plus e power x sin x. So you can see here that is minus and plus functions, that is nothing but plus and minus. So the opposite signs get cancelled, as we know. So the resulting final answer is y double dash is equal to 2 e power x cos x. It is really simple, isn't it? So you got your result.